Okay, before I go into the Nearpod, while everybody's getting logged in, if you go into Pearson, I want to show you where this is. I think I've showed you before, but I want to make sure everybody knows this because it's so important in this chapter. If you go into My Math Lab and go to Tools for Success, there is a graphing calculator tutorial to learn to use your basic TI functions. And this is a really, really good resource, especially for learning how to use the TVM solver. I think I might have showed you how to use it with the matrices at one point, and maybe how to do some other things. But this is the most important thing. And it is one of the applications. You just click on TVM solver. Now, I'm going to try to make this bigger so you can see it better.
I'm sorry, when I got applications, TVM solver, but what was the step before that?
You go to Tools for Success and choose the Graphing Calculator tutorial under Technology and Support. It's toward the bottom. There's 4 choices there, but you want the 3rd one down. Okay? So let me see if I can make this bigger. And apparently it doesn't work on this. Yeah, I wish I could make it bigger because it would work a whole lot better. Okay, the time value money, that's what TVM stands for, is time, value, and money solver. And what you want to remember, and I would suggest actually that you print out, you can actually print out this particular page. Print out this page so that you know what all the various variables are going to stand for. So in this problem, N is for the number of payments or compounding periods. So for example, if you were doing a problem, let's see, we didn't do present value last time, but we did one where it was compounded. Let's go back one on your Nearpod. So on Nearpod, we had the problem where we supposed that Susan Nassy invested $5,000 in a savings account that paid quarterly interest. No, that's not the one I want to do. Hang on. Because I want the one that does compound amount. Okay, example 5. Okay. No, I'm sorry, it's example 4. In example 4, we had $1,000 is deposited for 6 years in an account paying 4.25% per year compounded annually. Okay? So what I'm going to do is I'm going to record that information over here, and we're going to work through this problem on the solver. Yes? Let me come and make sure you know where yours is then. Did you find it?
It's fine. You said it's fine.
Yeah, and it's different on different TI-84s, unfortunately. That's why I would have to look at your calculator to find it. Sometimes it's a second function, and sometimes there's just a button. Okay, so I have written down here what we're actually looking at. I'm going to try to get these side by side for you. Okay, now on this list of variables for this problem, it says N is the number of payments or compounding periods. Okay, well, you're going to deposit it, according to the problem, 6 years. And it's compounded annually, so that's going to be 6 years times once a year. And then we'll go through and we'll do it again, compounded semi-annually and quarterly, so you'll see how these things change. And then, and that's capital N on your solver. It's little n in your formula, but it's capital N on the solver. And then the I%, the I% is the annual interest rate. So that's going to be 4.25%. And you do not change it to a decimal. That's the one thing to be cautious about. You do not change it to a decimal. You leave it as a percentage. And then the present value is how much you initially deposit. And then if you're going to make periodic payments into the account, then that's going to be PMT. Excuse me? The N on the calculator? We're going to go through it, but I'm just showing you how to fill out your information so that you'll be able to do it for each problem. We're not doing the problem yet, okay? And then FV is your future value. Which is also called the maturity value.
Is that A?
And that's A.
Okay.
Very good. So in your formula, that's what we always call A. And if you know all four, if you know any four of these, then the calculator will solve and find the fifth variable for you. Okay? Now, at the bottom of the screen, we see there that you have P/Y. That means number of payments per year. Payment per year. And then C/Y is the number of compoundings per year. And you have to decide, is the payment at the beginning or the end? Which won't come into play until section 5.3. So if we're doing this problem, we're not making payments. What we want to do is we want to find what's called the compound amount or the future value. Okay? So before I work through the one that's actually there on the tutorial, I'm going to bring up the calculator, work a problem we've already worked using the solver. So on the 83, it's not an app, it's on finance. Those of you that have an 83, press second and the X to the -1. If you have the 85, it's on apps. Oh, I'm sorry, the 84, it's on apps. So you go to TVM solver, So in the problem that we're looking at, the number of compoundings is once a year for 6 years. So n is going to be equal to 6.
I don't see that in my list when I hit X.
You may have to go to finance, let me look at yours and see.
Maybe I go and hit finance.
There you go. And it's the very first one on the finance menu. So we have 6 compoundings per year. The interest rate is 4.25%, and enter that as a percentage because it says percent. The present value is the $1,000 that you put in. You're not going to make any payments. So just gloss over that. Leave it blank if it's blank, or just, you know, you don't have to do anything with that. Now, the number of payments per year, they're going to pay you interest once a year. They're going to compound once a year. One of the keys to understanding this is that in order to use the solver, these two have to be equal. Payments per year and compoundings per year has to be the same. Like, for example, if you do a mortgage to buy a house, which is the example we're going to do in a minute, you do a mortgage to buy a house, you make 12 payments a year, once a month, and they compound your interest monthly. So you make payments once a month, and they actually reassess your balance once a month also. So in that case, your payments per year and your compoundings per year would both be 12. Okay? But in this case, it's going to be 6 years compounded once a year. The interest is going to be paid once a year. Okay? And then all you have to do, it says, what is the compound amount? Well, that's future value. So you put your cursor on FV for future value, what that number is there, and you hit your alpha and your enter button to solve. Your alpha and your enter button. Now on the 84 it may be different, so let me look. No, it's the same. It's the green button and then enter to solve. Okay? Now notice that it comes up negative. It's going to do that. But when we did the problem, that's exactly the same answer that we got when we did the problem. $1,283.68. Okay? Now, in this particular problem, that's not a really big deal because when we actually did the problem on Nearpod, it wasn't a big deal to substitute in those numbers. But the problems we're going to have for annuities and annuities due and mortgages and that kind of thing, they're a little bit more involved. And the calculations are a little bit tougher. So when you see some of these tougher formulas, I'm going to give you a formula sheet on the test, but you don't really necessarily need to know how to plug it into the formula. I want you to identify the information and plug it into the calculator on a solver and get it to give you the answer. Because this is not, I mean, you know, this is just arithmetic. And the calculator does much better, much better and more efficient job at doing arithmetic than we do. So going back to the tutorial again, the problem in the tutorial says, for example, and I'm going to slide it down here. Suppose you found a house on sale for $175,000. What would your monthly payments be if you financed it for 30 years at 7.5%? Okay, now that's a realistic problem that some of you may have to actually solve even if you weren't in business. Everybody needs to know how to do this kind of thing because eventually most of us are going to buy a house. What you do is you get your solver up, and on the 84 you do that by pressing the apps button, and notice that it's highlighted the key it wants us to press. So So this will walk you through a problem. And then you hit enter to choose the finance formulas, and then enter again to choose TVM solver. Now in this case, when you read the problem, your cursor is on N. That's the number of payments over the life of the loan. Now if you've got a loan that's 30 years and you make monthly payments, how many payments are you going to make? If you've got a loan for 30 years on a house and you're going to make 12 payments a year, how many payments will you make? Because that's what N stands for. Well, it's actually going to tell you to type in 12 times 30. You don't even have to figure that out in advance. You don't have to say 12 times 30 is 360. You can actually do the arithmetic right there. That way you don't mistype, make a mistake. And then you hit enter. And then when you're sitting here next to the interest rate, it said the interest rate was 7.5%. Enter. And now you're on present value. Present value is what they're charging you for the house. It's what you borrowed. So that's the $175,000. The payment is what we're looking for. So we don't put anything in for that. We skip that. If it's blank, you put a 0 there. The future value, we don't really care. So we're going to leave a 0 for that. The number of payment periods is 12 per year. Because you pay monthly, there's 12 months in a year. And the compounding is the same. It's also 12 per year. Okay? And usually when you type in P/Y, it will duplicate that number in C/Y. And if you change C/Y to something else, it will change P/Y to match it. So you don't have to remember that those have to match. It matches those for you.
So the N is the total number of payments
Mm-hmm.
throughout the life of the loan.
Right, you're going to make 360 payments. Now what we want to know is we want to know what is the payment going to be. So you move your cursor up and put it next to the payment variable. And then you press your alpha button and your enter button to choose solve. So your payments on that house are going to be $1,223.63 every month. Okay? Now the other thing you might want to know for that same problem, that same situation, is I'm going to go and use my apps again. I'm going to go to finance on the 83. And here again, 12 payments a year times 30 years at 7.5% interest. And the present value is $175,000. I want to know what I'm ultimately going to pay for the house. The 175 plus the interest. What am I ultimately going to pay for the house? So I'm going to put my cursor on future value, not payment, and press alpha, enter. And it says, oh, yeah, that wouldn't work too well. I forgot to change that to 12. And notice that, like I said, it matched that up. So let me solve again. I'm gonna pay $1,648,768.43 for that house. That costs less than $200,000. Okay? Now, right now, interest rates are not 7.5% on a house. They're a lot lower than that. But even at a much lower interest rate, I think you could probably get a mortgage right now for probably about 3%.
What about an interest rate on a car?
It works the same way as this does. The
Is that
interest,
like ballpark what it'd be right now?
probably, depending on your credit and where you finance. At my credit union, my car payment now, my car loan is 2 years old. Mine's like, I wanna say 2%.
For a car,
Yeah,
Yeah, aren't interest rates like for a car right now like ridiculously low?
they are ridiculously low right now, you know. Hmm? Yeah, some of them are zero.
This is like real life, because I want to get a new car. Like,
Well, and, okay, piece of advice, if you can get credit at a credit union, my car payments are lower than they would be if I had financed through my bank because I went to the credit union and, it's simple interest.
yeah, see, I have no credit score.
Oh, you have one, you just
I
don't know what it
don't know
is.
what it is, yeah.
So let's suppose we had 3% interest rate on a mortgage, which I think is probably pretty easy for anybody to get right now. Let's see what the future value would be. Okay, now look how much money we saved by dropping the interest rate. You pay $429,947.38 for the $175,000 house. So you pay a little less than $500,000, but it's better than over $1 million. And your payments would be let's see, I think you have to leave. I think you have to make that 0. And your payments would only be $737.80 a month, which is considerably better than over $1,200 a month. So the interest rate makes a big deal, okay?
so how do you start doing that real rate when you start adding in your escrow and taxes and all of those good things?
You can't do that really easily on the calculator, but the banks have a finance calculator that they just plug it all into and it spits it out. And some banks don't do escrow. Some banks, you pay your own taxes. Yeah, you can make the choice of whether you want to have escrow that'll pay your property taxes and your house insurance, or do you want to pay them on your own?
Okay.
And in the long run, honestly, I think you're better if you have the choice to buy your own and pay your own property taxes, because that way all they're doing is forcing you to save the money to do it. And you're not getting any interest on your money, so. So that's how you use the solver, okay? And we want to be able to do that to solve these problems. So now we'll return to the PowerPoint, and we will pick up at present value. And this is a very useful concept. If you know some future amount of money that you need to have, this is actually leading into the idea of an annuity. If you actually know how much money that you need to have at some future point in time, and you know what interest rates you can get and exactly how long it's going to be before you need that money, you can figure out how much money that you need to put in the bank today and just let it sit there to have the amount of money you're going to need somewhere in the future. Say you're trying to make sure that you have enough for a down payment on a house at some point in the future. So maybe you got your income tax refund back this year, and you're thinking, okay, I know I'm gonna need $5,000 down on a house, a car, whatever, in 3 years, because my car, I'm expecting it'll last 3 more years or whatever. So how much of my income tax refund can I put in the bank right now at some set interest rate so that in 3 years I'll have the amount of money that I need? And that's what this formula does for you. So present value is the amount you put in today to have a future value A, or a compound amount A, at the end of the period. So here we have Stacy, whatever Stacy's last name is, Stem, must pay a lump sum of $6,000 in 5 years. What amount deposited today at 6.2% compounded annually will amount to $6,000 in 5 years? Okay, now that $6,000 is what's called a future value. In your formula, that's A. On your solver, that's FV. And 6.2% is the interest rate. And remember, that's the annual interest rate. That's what you always want. And on your solver, that's going to be I, or I percent, because it actually spells out percent on the solver. But in your formula, it's still I. It's still I. And then it says they're going to compound annually. So your payments per year and your compoundings per year are both going to be 1 for once a year. In your formula, that's negative N. And it says in 5 years, so you're going to have 5 payments and 5 compoundings. And on your TVM solver, the total number of payments is only actually going to be 1. We're only going to compound it. We're only going to put in the money 1 time. So our present value for this is what we don't know. The interest rate is 6.2%. The number of payments that we're going to make is 1. And it's compounded annually, so that's once a year. No, I'm sorry, N is not 1, N is 5, because it's 5 years.
So I'm confused. So the number of payments is 1, but it's the time that we're supposed to put in N?
Yes. Let me double check, make sure that I didn't say that wrong. the number of payment or compounding periods. And because it's compounded annually, they're gonna compound it 5 times. They're gonna do it once a year for 5 years,
So
okay?
that's the PMT is 5.
No, the PMT is the amount of payments you'd make, and we're gonna leave that 0. So the number of compoundings, the number of times they compound the interest is once a year for 5 years, so that makes that 5.
Okay, that's
Okay.
PYCY.
Right.
Okay.
And then 6.2% is our annual interest rate. The present value, we don't know, that's what we're wanting to find out, so we're gonna put in a 0 for that. We're not gonna make any payments, so we're gonna put in a 0 for that. But we want the future value to be $6,000. Okay? And then you put your cursor on your present value and hit enter. Or, I'm sorry, alpha enter. And it says you'll need $4,441.49. You getting a different answer? Make sure I didn't enter something wrong.
No, it's 7.
But you got a different present value?
Yeah,
How much different?
a lot different.
A lot different. Let me see.
I may have done something right.
No, you're solving for payments. You were solving for payments, present value. Present value, not payments. Present value.
Okay, so I have questions.
Anything you don't know or don't need, leave it at 0.
So N is 5.
Because it's gonna go paid 5 times, once a year.
Because PYCY I have is 5, but that's 1.
And that's the payment, remember that's payments per year or compounding per year,
And then the 5 is.
the number of years.
Which in the old way that would be real N,
Right,
and then this way would be bigger.
right.
Okay.
Okay, and the reason that what you wanna do is you wanna solve for the present values, such as that. So you need to put in a payment of 0, so that it will substitute anything else in for payments,
Okay,
okay?
okay.
Okay? So the key to using the solver is you only solve for the one thing you don't know, and if it has a piece of information it's asking for that you don't need to use, put in a 0 for that piece of information, like for payments, we're not making any payments. Okay? So just put in 0, we're making no payments. Now, if you wanted to know in the same scenario, instead of putting in all the money up front, what kind of payments could you make into the account? Then you would put your present value at 0 and then go solve for your payment amount. It will tell you how much you could deposit once a year for 5 years and achieve the same thing. Okay? So basically what the calculator did in a few steps is exactly the same thing as what the formula would do. Your formula, A equals P times 1 plus the interest rate to the n power. And you want to solve it for the present value. You can actually, you don't even have to have that other formula. You can plug right in here and do some algebra. So your future value is going to be $6,000 is equal to the present value, which I don't know what that is, times 1 plus, now if you're doing the formula, you have to change it to a decimal, so it's 0.062. And the number of times it's going to be compounded in 5 years, once a year, is going to be 5. So then P is going to be, let's divide that off of both sides. P is going to be 6,000 divided by the quantity 1 plus 0.062 raised to the 5th power, which is $6,000 divided by 1.062 to the 5th power. Y'all watch me on this calculator because it's putting in, I mean, it's doubling some of my keystrokes. So kind of watch in case and help me not mess that up. So we get the same exact amount by doing it by hand. But the solver is faster once you get all of the different variables in the solver figured out. That's the main thing. Okay? So what the solver is it just has all of the different kind of interest rate formulas built into its memory. And if you give it the values of the variables, it will run those formulas and give you the answers. Okay? So example 9 says find the present value of $16,000 in 9 years if the money can be deposited at 2% compounded semi-annually. So here again, we're going to go to the finance formulas and to the solver. And N is how many times are they going to pay you interest? Well, 9 years semi-annually is 9 times 2, twice a year. The interest rate is 2%, so just put in a 2. We're looking for present value, so we enter a 0 for that. We're not going to make any payments, so you leave a 0 for that. And then your future value is $16,000. And you're going to only pay once a year, or they're going to pay you twice a year. I'm sorry, not once a year. You're going to pay you twice a year. And that's because interest is compounded twice a year. And then you go back and put it on your present value. Be sure it's on present value and that there's a 0 in payment. And hit alpha, enter to solve. And it says the present value of that $16,000 you're going to need in 9 years. If you'll put $13,376.28 in the bank right now and leave it alone, then in your 9 years you're going to have the amount that you need, which is the $16,000. Okay? And again, you can plug it into the formulas here if you want to. But I just think the solver is very, very much easier, and it's going to be way easier when we get into the more complicated formulas. So there's your algebraic solution, and you see that you get the exact same answer. Example 10 says, suppose the $2,450 from example 5 is deposited at 5.25% compounded quarterly until it reaches at least $10,000. How long is that going to take? Okay, now that's a little bit different problem. We actually have two different methods for doing this. One is using the graphing part of the calculator. And what you're going to do on the graphing part of the calculator you're going to go to your y equals menu and you're going to enter the future value formula. Okay? The future value formula for this particular problem, and I'm going to back up one so I can make notes about what everything is. We've got 2,450 is deposited, so that is the present value. And your interest rate is 5.25, so 0.0525. But it's compounded quarterly. So you're going to divide it by 4. Okay? Until it reaches at least $10,000. So the way we're going to put that in the calculator is your present value is $2,450 times 1 plus the interest rate divided by 4 and that's going to be raised to the x power because that's the variable, that's what we don't know. We want to know how many times or how many compound is it going to take for us to reach our goal. So actually what you'll have here is you'll have a caret and then the x to show the power. So I'm going to go ahead and type that in. Be sure and put parentheses around your interest rate if you have to divide it. And then close both sets of parentheses, raise it to the power x. So what this is it's basically future value is equal to the present value times 1 plus the annual interest rate divided by the number of times you compound per year, and what we don't know is the year, so that's going to be our x, okay? The number of compoundings that we need. Now, since we know our goal is to reach $10,000 at Y2, you put in $10,000. Okay? Now, since I don't really have any idea how long this is going to take, I'm going to go for longer rather than a shorter period of time. And I'm going to think, well, okay, I'm trying to get to $10,000 and at, only $2,400, $2,500 right now, that's going to take a little while. So I'm going to go to my window. Time never goes negative, so I'm going to start at 0 years. And I'm gonna let it go for about 30 years. And if I need to, I can change that. And then I know that the top of my window needs to be at least $10,000 for me to see that other line. So I'm gonna put in something bigger than $10,000, like maybe $15,000. Or you could put in even just 11,000 or 12,000. And then I'm gonna hit graph. I'm going to make some notes here for you so that you'll have them in the recording. When you set your window, X min is equal to 0. And that's because time's not negative. X max, we're going to try 30. Well, we're just going to try that as a starting point. Better too big than too small. And then how you increment that X scale, it can be 1, it can be 3, it can be 10, whatever. I'm just going to leave it at 1. And then Y min, all that matters is it's equal to or greater than 0, but the reason I left mine at -10, so when it draws my graph, I'll be able to see down here. So as long as it's equal to or greater than 0, but I put mine in -10. And then Y max, I set at 15,000. Because it has to be greater than 10,000 because of this. Okay? So there's a little bit of thinking about how you would have to do this. And then you just hit graph. And wow. Let me go back and check, make sure I entered that right, because I'm pretty sure that it should have made it. $24.50, 1 plus 0.0525 divided by 4 raised to the x power. Oh, I see what, yeah, okay. I wasn't thinking about it being quarterly. So I'm going to go back, and even if you hadn't realized it that way, what you see here, are those two lines ever going to intersect? At some point, because one of them is traveling uphill, right? So what I need to do is I need to see further in that direction. So if I can do this to where it'll make some sense to you, let me put this down here. This is Y max is at the top of your screen. Y min is at the bottom of the screen, obviously. It's not going to go below that. This is X min on this side. And this is X max on that side. So if I need to see further in that direction, what I need to do is I need to raise X max. And obviously I need to raise it quite a bit because I've got it for 30 there and they're not even close yet. So what I'll do is I'll go back to my window and I'm going to pretend I'm not even looking at their figure. I'm going to pretend I'm doing this by myself because you will be. And so, okay, 30 obviously wasn't enough. How about 150? there it goes, crawling up the screen.
I'm having issues with that.
Okay. You need a second set of parentheses after the divided by 4, because you got 2 of them open. Yeah, so you have to close both of them before you apply the power.
Okay.
Yeah, there you go.
Thank you.
You can put your second function, that's where your 10,000 is. Mhm. So here's what we're seeing. Now I'm going to hit the trace button. What you're seeing is that this is the way your money's growing. Okay? And I'm going to start out here where x is equal to 0. And I'm going to trace from there. Go second, trace to the calculate menu. Choose the very first thing, and it lets you plug in an x value. Choose value, and then it'll go straight to whatever x you get. I just wanted to, I started at 0 because that's what I put in on day 0. That's what I put in to start. So now watch what happens as time goes on. If I keep tracing, notice that as x increases, and remember x is the number of times it gets compounded. As x increases, the amount of money I have in my bank is also increasing.
Oh, wait, I don't know.
Okay, so be sure you're actually on trace, and you can get pretty close. Right there, I'm not quite at $10,000 yet. But if I go one more, I'm past $10,000. So sometime at around 107 compoundings, at 107 payment periods, I'll have at least $10,000.
How do you make yours follow your curve?
You press trace.
Oh, you just keep pressing it?
No, you press trace and use your right arrow.
Ah,
Okay?
follow the line.
Now, if you wanted to find the exact amount, what you can actually do is you can go second, trace again to the calculate menu and choose intersect, number 5. And just make sure that you're actually on both lines. So yes, I want you to take this line and that line and tell me where they intersect. So just enter, enter, enter after you do intersect. And it says at exactly 107.86.
Okay. So you do trace. Second
So this is the $10,000 goal that we had. And it's basically, you can't have 0.86 of a payment period, so this is actually going to be at 108. And since they do those 4 times a year, we'll divide by 4.
I'm sorry. I just got confused on the calculator. how did you say you can go right to the intersection point?
You press second, trace,
Trace.
number 5,
Second, trace.
and then enter, enter, enter.
And-
Okay?
Okay, I know it. That's second,
I'm recording it too, Janice.
trace. Okay.
Can you do the, can you get the integrities? That way, if you get stuck at home, you can go back and watch this.
Okay. So then you said once we found our intersection point
The-
at 107.
0.86 and 10,000. $10,000 was our goal. That was what we wanted to have, was $10,000.
Okay.
And we got our $10,000 after interest was paid 108 times. But it said how many years? Well, you compound 4 times a year, so that's 108 payments divided by 4 to get how many years? So it'll take about 27 years. So if you want $10,000, and you can put $2,450 in the bank today at, back over here, at 5.25% interest, then in 27 years, you'll have $10,000. You just have to put it in the front end and wait. Okay? You can also use the TVM solver to find the same exact thing. Your number of compoundings is 4 times per year for 6 years, so that's 24. And your interest rate was 5.25% per year. Your present value is how much you put in to start with. I don't think I'm working the same problem. Let me go back. No, I'm not. Back here in example 6, we had the number of years was 6 years, the compound amount at the end of the period, so the future value we were given as 6539.96. And the number of payments, since it was compounded quarterly for 6 years, is 24. And the interest rate, it will calculate. The payments per year is 4 per year, and the compounding is 4 per year because it's quarterly. And what we put in to start with was $5,000. You always want to make that negative. Oh wait, no, clear, sorry. That's 0. Putting it in the wrong place. And if I wanted to, I could try to solve to see what interest rate that I needed to get with this. So if I put my cursor on the interest rate and do alpha solve, it says I would need 4.5% interest rate. And that's the annual interest rate. Okay? That's not the periodic interest rate. So you can use the solver to help you out with a lot of different things. And we also have something called continuous compounding. Suppose a bank, in order to attract more business, offers not just compound interest every quarter or every month or every day or even every hour, but constantly. Okay, constantly, every single second of every single day. It's called continuous compounding. And in example 5, we had that $24.50 deposited for 6.5 years at 5.25% compounded quarterly, and we got an annual amount of $3,438.78. Now, same situation. This one is the same amount to start with. They compounded quarterly. Let me go back to the Nearpod here. If they compound it quarterly, then your compound amount at the end is $34.3878. If they compounded it monthly, which instead of being 4 times a year, they compounded 12 times a year, well, you gain about $5.10. You get a little bit more. If you do it daily, that's 360 times, remembering that they always say that a year is 360 days, even though it's 365. Then you'll have about $3.30 more than you would on monthly. And if you do that for every hour, which is your 360 days times 24 hours in a day, then notice that you don't gain that much. You only gain a few cents. But there actually is a formula that you can plug in and do continuous compounding. And the E that you see in this formula is actually a number. It's an irrational number, just like pi. So if we do this formula, and I'm going to write it down so we can do a problem right quick. The future value is the present value times the quantity E to the RT dollars. RT is going to be your interest rate. T is going to be the number of years. So let's see what the continuous compounding will get us. So what we're going to do is we're going to evaluate the formula. 2450 times E raised to the 0.0525 power, and for 6.5 years. And your E is the second and the LN next to the number 4. And then you have to put your power in parentheses, and you need to spell out your multiplication. So it's 0.0525 times 6.5 for the number of years. And then close your parentheses. And hit enter. And you'll have 34, 46, 42. So actually, if we look back, 34, 46, 42, they would be the same as if we did every hour. Okay? You might make an extra penny. So there's the algebraic solution, the arithmetic solution. And if we want to find the effective rate, all we do to find the effective rate is remember that that's gonna be E raised to that interest rate power minus 1. You have a formula for effective rate.
Okay, so the effective rate is.
E raised to the interest rate power minus 1.
Times one.
Mm-hmm. No, minus 1, subtract 1. Minus,
That's always.
always, that's the formula. If it's continuous compounding and you're trying to find the effective rate for your interest rate, you just take E raised to your interest rate and subtract 1 and you'll get your effective rate. And this one you would be solving for the amount of time it took. We'll finish up with this one on Monday and go ahead and do the next section. Or not Monday, Tuesday. Okay?